Hey guys, welcome to question MM438 of the Maths Methods Fortify study guide. So we've got this question that has a continuous random variable x, which has a probability density function given by f of x equals x squared over 3 from 0 to a and 0 elsewhere. Find the value of a in the form 3 to the power of b on c, where b and c are positive constants. Awesome. So first thing to remember about this is that with a probability density function, the area underneath the function is equal to 1, right? Because the total probability of anything happening is 1. So our area, 1, is equal to our area, or our integral, from 0 to a, so from our lower to our upper, of x squared over 3 dx. Integrating this as normal, we add 1 to our power and divide by the new power. So divide by 3, so 3 times 3 is 9, from 0 to a, and that's equal to 1. Now, this is our first mark here. This is a 2-mark question. As we can keep going, we just work down the list. So sub in our value for a, so we get a cubed over 9 minus 0 cubed over 9. So we've just subbed in our a and our 0. 0 cubed over 9 is just 0, so we get a cubed over 9. That's equal to 1. So we get 9 equals a cubed. So a is equal to the cubed root of 9. Now, the cubed root is the same as doing something to the power of a third. So what that is 9 to the power of a third. But we want to answer in the form 3 to the power of b on c, which means we're going to have to get a base of 3. So 9 is the same as 3 squared. So we do that to the power of a third. And then 3 to the power of 2 to the power of a third. This 2 and this third can multiply, so we get 3 to the power of 2 over 3. And that's equal to a. That's our second and final mark for part A. Let's move on to part B. And part B asks us to find the median of x, which is the point where 0.5 of the data, or half of the data, lies on either side. So we get 2 marks there. Just write that out elsewhere. Awesome. Now, we're looking for the median. So, as I said, the median is the point where half of the data lies on either side, which means that we've got an area of 1/2 to the left of our median. So our area from 0 to our median is 1/2. So our median lies somewhere between 0 and a, and the area from 0 to m is 1/2, and the area from m to a is 1/2, right? We've actually just found that a is equal to 3 to the power of 2 on 3, so I'll just change that there as well. Awesome. So again, we've still got our function x squared on 3 dx. And again, we can just integrate this as normal, so we end up with x cubed over 9 from 0 to m, and again, this is our first mark, and this is equal to 1/2. Now we get m cubed over 9 minus 0 cubed over 9, that's equal to 1/2, and 0 cubed over 9 is just 0, so that can cancel, and then we can multiply both sides by 9, so we get 9 on 2 equals m cubed, which means that m is equal to the cubed root of 9 on 2. And that's it. So that's our second and final mark for part B. Let's move on to part C. Part C is a 1-mark question and should be fairly straightforward. It asks us to find the probability that x is less than m, given that x is greater than 0. And so this is equal to x is less than m intersect x is greater than 0 over the probability that x is greater than 0. Awesome. So, because m, actually, you know what, let's check out our the probability that x is less than m and greater than 0. The intersect of that is, let's say, from 0 to m. Now, from 0 to m, 0 is our lower bound, right? So from 0 to m, the probability of that is actually 0.5, right? Because the probability of lying between m and the lower bound is 1/2, so we actually have 1/2 there, okay? Now, 1/2 is this probability. The probability that x is greater than 0, 0 is our lower bound, which means that everything above it is actually just 1, right? Because the probability that x is greater than 0, it can't be less than 0, which means that the probability that it's greater than 0 is 1, right? Because it includes everything above that, which means we've got a 1 there. So this is equal to 1/2. That's our first and only mark for part C, and that actually wraps up MM438. So guys, if you have any questions about any of this, as always, let me know in the comments below. But otherwise, thank you for watching, and I'll see you in the next video.